Hi, welcome to Technical and Engineering Academy. This is Blessed Elvis. Okay, so the Bernoulli equations, also known as the nonlinear differential equations, are quite similar to the linear differential equations, except that for this one we have y raised to a certain power for the q of x. So make sure that you watch the video on linear differential equations, which I did, for you to have a clear picture of whatever we are going to do now, because that's linked to this one. So linear is linked to nonlinear. Okay, so in this case, the nonlinear differential equations, also known as the Bernoulli equations, are the equations of the form where you have the first derivative added to p of x of y equated to q of x, y raised to a certain power. So the n here just represents the power that you can be given, where n is not equal to 0. So the value of n should not be equal to 0, because if it's equal to 0, then here we are just going to have, in this case we're going to have this, and we know that n value raised to power 0 is just 1, so 1 multiplied by q of x, then it's q of x. So if n is equal to 0, then this function becomes a linear differential equation. So now the nonlinear differential equation is where the value of n is not equal to 0. So n should not be equal to 0, then that function is a nonlinear differential equation. So that's it. So this is the standard form of the nonlinear differential equation. This. Okay, so after that, the integrating factor in this case is found by e raised to power 1 minus n of what? Of p of x. You integrate it. So this is how it is. Okay, so we did this in the linear differential equation, so make sure you refer to that. So yeah, this is the integrating factor formula. Then the formula for the general equation is where you have y raised to power 1 minus n equal to 1 over the integrating factor. Then in this case we are going to have 1 minus n, and then integrating factor multiplied by q of x dx plus c. So this is what makes up the Bernoulli equations, or the nonlinear differential equations. So the first is writing the expression in this manner. After you write it in this form, then you find the integrating factor. After you find the integrating factor, you replace in this general equation and simplify. That's all about this. So let's look at examples. So let's say you have y, moreover y prime, of course we know this is the same as dy over dx, so make sure that you don't get confused. Take note of this. So where you have y prime, it's the same as dy over dx. So we can either use this one or they can use this one. It's just the same thing. So in this case, I'll use y prime. So let's say you have y prime plus x y equal to x e raised to power negative x squared, then y power negative 3. So how can we go about this one? So the first thing, or rather the first step, is identifying what? Is identifying your value of n, the value of the function q of x and p of x. So in this case, remember our function was y prime plus p of x y equated to q of x, what? Y raised to power n. So let's identify the values. So in this case, we have our p of x. P of x is whatever is on the y here. So our p of x, of course, is just x. Then our q of x is any function here apart from where you have y raised to power n. So in this case, it's just this. So in this case, it's going to be x e raised to power negative x squared. Then our value of n is what? So the power we have for y is just negative 3. So our value of n is negative 3. So these are the values that we are going to be using in this case. So we have identified the values for the functions and the value for n. So in this case then, after you have identified that, you have to find the integrating factor. And we know that the integrating factor is where you have integrating factor, in this case in form of x, equated to e power 1 minus n, then p of x dx. So let's replace that with the functions that we had. So in this case, it's 1 minus, what was our n? Our value of n was negative 3. So in this case, it's negative 3. And then our p of x was what? Was simply x. So we have x. Then g of x. Okay, so let's simplify that before we find the integrating value. So in this case, then we know that negative and negative is positive. Then 1 added to 3 is just 4. So we have 4. And then here we have x. So then dx. Okay, so in this case, then we have our integrating factor equated to e power of what? Of 4x dx. We are integrating. So in this case, this is the same as e. We can take the constant value outside and then here remain with just x, then dx. So in this case then, this is the same as where we have x. When we integrate x, we are going to have what? What are we going to have when you integrate x? Of course, when you integrate x, we are going to have, okay, let's write this here, equal to e. So here we are going to have x, 4x. Here we have 1. So the power of 1, when you don't have a power on a certain number or a variable, it means there is power of 1. So according to the integrating rules, you add 1 to the power and then divide the same power. So in this case, we are going to have 1. So we add 1 to the 1 we already have, it's going to be 2. So here it's going to be squared and then divide the same value here. So in this case, you can simplify this. Then 2 into 4 is just 2. So in this case, it's going to be power of 2x squared. So this is our integrating factor. It's going to be e 2x squared. So this is our integrating factor in this case. So since we have already found our integrating factor, which of course is just e raised to power 2x squared, we are going to replace this in the general equation. Remember, our general equation is y 1 minus n equal to 1 over the integrating factor, and then here we have the integral of what? Of 1 minus n, then integrating factor, and then here we have q of x dx plus constant c. So in this case, we are going to replace the values. Remember, what was our n? Our n is negative. Our n is negative 3. So we have 1 minus negative what? 3 equal to 1 over our integrating factor. We have already found it. It's e power 2x squared. Okay. Then in this case, we are going to find the integral of what? 1 minus negative 3. And then our integrating factor, we already have found it. It's e raised to power 2x squared multiplied by, what was our q of x? Okay, our q of x was x, e power of negative x squared, then dx. Okay, then plus constant value c. Okay, so let me just write this properly. So we have y 1 minus negative 3 equated to 1 over e 2x squared. Then we have the integral of 1 minus negative 3, and then our integrating factor is e raised to power 2x squared, and then our q of x is what? X e power negative 2x. Rather, it's just x, sorry, it's just power negative x according to the quotient squared. Okay, and then we have dx plus constant value c. Okay, so let's simplify this. So 1 minus negative 3, so negative and negative is positive, then 1 added to 3 is 4. So we have 4 there, over e 2x squared. Okay, so even in here we have in the brackets 4 e power 2x squared, and then in the brackets there we have x e power negative x squared dx, then plus the constant value c. So let's integrate this. Okay, so we know that 4 here has to come outside the integral, so that we have y raised to power 4 equal to 1 over, in this case we are going to have e power 2x squared, okay, then 4 outside the brackets here. Now when we have, okay, in this case, okay, let me just, so here we have e power 2x squared, that's what we are meaning with, and then here we have x e power negative x squared, then dx plus constant value c. Okay, so in this case, let's simplify this further before we find the value. So this is the same as e power 2x squared. Okay, so in this case, we have 4 outside here. Now, according to multiplication rules, when you are multiplying the same bases, you simply add the what? The powers. So let's just write x here. Since we have e here and e here, it means we are going to just write e and then add the powers. So we are going to have 2x squared, then plus negative x squared dx, then plus the constant value c. So let's just create space on top here, since we have already simplified this expression. So when you are multiplying the same bases, you simply add the powers. When you are dividing the same bases, you simply subtract the powers. So that's according to the rules. So in this case, we have 1 over e power 2x squared. In this case, outside here, we have 4 and then x. So in this case, where we have positive and negative is just negative. So we are going to have e power x squared, then minus x squared, then dx plus constant c. So we can remove this. Okay, we can simply remove this so that we create space. So in this case, then we are going to have y power 4 equal to 1 over e x squared. Okay, so in this case, then we have 4 outside here. Let's simplify what we have here. So it's x e. So 2x squared minus x squared is simply x squared dx plus the constant value c. So in this case, now we have this, so we can find the integral of x e power x. So what is the integral of e power x? Okay, of course, we know that the integral of just this part here is just 2e x squared. So we are going to have then y power 4 equal to 1 over e 2x squared. We are going to have, in this case, we had 4. So the power of x to the e, we put it here and then we write the same thing. We are going to have e power x squared. That's how we integrate. You write this power here down there and then you divide in there. So we are going to have 1 over e 2x squared. So 2 into 4 is just 2e x squared plus the constant value c. So in this case, we can multiply throughout this in here. So what are we going to have? So we're going to have y power 4 equal to 2e x squared over e 2x squared plus constant c over e 2x squared. So we can simplify this. So it's y. However, this is already done, so if you just want to simplify, that's how you go about it. However, you can just end it up to here. It's just fine, and it's very, very much okay. Okay, so in this case, we are going to have e. So remember what I said? I said either that when you are dividing the same bases, you subtract the powers. So in this case, it's the same as e x squared minus 2x squared, then plus c here over e 2x squared. Okay, so I'm just simplifying, otherwise the general equation has already been found. You can simply end it up to where I am rubbing from, unless you just want to simplify further. That's how to go about it. So here we have y power 4 equal to, so in this case, x squared minus 2x squared. We know when you are subtracting the smaller number from a bigger number, you are going to have negative x squared, then plus. Here, when you have this, of course, this is the same as 1 multiplied by 1 over e 2x, of course, power 2. Because c multiplied by 1 is just 1. So there is no difference to what I have done. I have just moved the c so that I can simplify even this expression here. So we are going to have y 4 equal to 2e power negative x squared, then plus. We know that when you have, let's say, 1 over 2, this is the same as 2 power negative 1. When you have 1 over x, this is the same as x power negative 1. When you have 1 over anything, it's the negative power or the inverse of whatever you have there. So in this case, writing like this is the same as having e power negative 2x squared. So this is the general equation according to the question that you were given. So this is how we go about it. So let's look at one more last example so that we can, of course, understand further. So let's say you have x squared dy, then plus, let's say, let me just write that properly, plus y, then x added to y, d of x, sorry for that, so d of x equal to 0. When we have such an expression, how can we go about it? So the first step here is to, let's divide the x so that here you can have a differential equation. So in this case then, we are going to have, okay, let's simply multiply this by 1 over dx. So we are going to have x squared here, dy over dx, plus this dx and this dx here we will cancel. So in this case then, we are going to have y x plus y equal to, of course, dx into 0 is simply 0. So again here we can simplify further. Let's first multiply this y into this expression. So we are going to have x squared dy over dx added to, okay, so what is y multiplied by x? Of course, it's just xy rather. Then y multiplied by y is y squared equal to 0. So let me wrap the top part here. Okay, so wrapping the top part so that we can clear space. So in this case then, we have this as the equation, but this is not the general equation, because the general equation, according to the standard form, here we just have to have dy over dx. So in this case, how are we going to do, how are we going to do that? So we are going to divide this x squared throughout so that we can just remain with dy over dx. So let's do that. So we are going to multiply 1 over x squared throughout. So in this case, we have x squared dx, dy rather over dx, added to x, y, plus y, equal to what? Equal to 0. So let's, this and that we will cancel. Here we are just going to remain with dy over dx, plus here we have x over x squared, y, plus y over x squared equal to 0. So let me just wrap this part down here. Okay, so even the top part here, since we have simplified the expression. Okay, hopefully you are following up. So in this case then, we have this. So let's simplify. So we have dy over dx plus x over x squared. We know that x on top there will go into the x squared, and then we are going to have x down here. So we have y, then plus, this is the same as 1 over also x squared y. Rather, there is a square here. Sorry, I forgot to write a square here. When you multiply y multiplied by y, we are going to have y squared. So it's y squared here. So make sure you take note of that. Okay, so we have that expression now. So we can take this other one to the right side, because according to the rules, the value of q, or the function of q, should be on the right side. So we are going to have dy over dx plus 1 over x y equal to, when this comes to the other side, it's going to be what? Negative. So it's going to be negative of 1 over x squared, then y squared. So then we have written the given expression in a standard form. Now we can go further and find the integrating factor. So we can do that. So firstly, let's identify the values. So in this case, our p of x is what? Is 1 over x. Then our q of x is what? Of course, negative 1 over x squared. And then our n is simply 2, because the value of n is simply the power of y. So these are our values that we have. So let's replace now. So according to the integrating factor formula, this is the standard form of the integrating factor. So we raise it to power of 1 minus n, and then p of x, then dx. Okay, dx here. So let's replace. Okay, make sure that you are writing the values so that you don't get confused. So in this case, we have 1 minus our n was what? 2. And then our p of x was what? 1 over x. Okay, then dx. So in this case, then we're going to have the integrating factor equal to e. Okay, so in this case, what is 1 minus 2? That's negative 1. So negative 1. Then 1 over x dx. So let me just wrap the top part here. So this is the simplified function, or rather the expression or equation that we have. So in this case then, our integrating factor is going to be e. So we know that a constant number, whenever you are integrating, can be written outside the integral factor. So in this case, it's going to be negative 1 integration of 1 over x dx. Okay, so what is the integral of 1 over x? So according to the rules, the integral of 1 over x is simply ln of x. So in this case, then we are going to have e power negative 1 ln of what? Ln of x. Okay, so we know that writing like this is the same as saying e. According to the logarithm rules, when you have a value here, you simply write it as the power of what you have here. So in this case, we're going to remain with ln of x power negative 1. Okay, so in this case, we are going to have, let's simplify this. So when you have ln, or rather e power ln of anything, you simply write whatever you have here. So in this case, then we are just going to write x power negative 1. So we know that the inverse of any given function or any given expression is the same as 1 over that given expression. So in this case, the inverse of x is the same as 1 over x. So in this case, then our integrating factor equals to 1 over x. So that's our integrating factor value. So let's now replace in the general equation. We know that the general equation is y 1 minus n equal to 1 over integrating factor, then the integral of 1 minus n, rather minus here, then integrating factor, okay, this is I, integrating factor, then multiplied by q of x dx plus the constant value c. So in this case, then we have y power 1 minus, what was our value of n? It's 2, equals to 1 over, what is the value of the integrating factor? It's simply 1 over x. Okay, so in this case, we have the integral of 1 minus our value of n is 2. Then our integrating factor is 1 over x. Then remember, our value of q of x was what? Negative 1 over x squared. So dx here plus constant value c. So let's simplify that. So we have y. Okay, let me just rewrite the expression. So we had negative 2 here equal to 1 over x. Then we had 1 minus 2. And then we had 1 over x. Then we had negative 1 over x squared g of x plus constant value c. So let's simplify this. So we know that 1 minus 2 is simply negative 1 equal to, now when you have, this is the same as 1 divided by x. Okay, so in this case, what is 1 minus 2? Simply negative 2, rather negative 1. Okay, so in this case, we are going to multiply this x multiplied by negative x here. Of course, it's simply, so we are multiplying with negative 1 over x multiplied by x squared is x power 3. Okay, then dx plus the constant value c. Okay, so let's simplify this further. So we have y power negative 1 equal to, so this is the same as 1 multiplied by x over 1. Okay, so in this case, then we have negative multiplied by negative, it's just positive. So in this case, we are just going to have 1 here. And then in there, we have 1 x power 3. And then multiplied by dx plus the constant value c. So let's just rub this. There are a lot of things here. So let's just remove the top part here. So this is how we go about this. So before you simplify, make sure that, or rather before you integrate, make sure that you simplify the expression as much as you can. So when you have the inverse of y, it is the same as 1 over y. I am from talking about this. Then this and that can simply cancel, so that here you have what? X. Okay, then inside the brackets here, remember 1 does not affect anything, so this is the same as just having the integral. So 1 over x power 3 is the same as x power negative 3. Then dx plus the constant value c. So in this case, then you have 1 over y equal to x. Okay, so according to the integrating rule, you add 1 to the power and then you divide the same power. So in this case, we have negative 3, so we are going to add 1. So 1 added to negative 3 is what? Is negative 2. So we divide the same power, which is negative 2, and then plus the value constant c. So this is how we integrate according to the integrating rule. So let's simplify this further. Okay, can we simplify this further? So if you can't simplify further, then that's your general equation. But if you can simplify further, make sure that you do that. So in this case, then you have 1 over y equal to, so we can multiply this x with whatever we have here. So in this case, we are going to have x, and then we know that whatever you have here is the same as x, rather this is x, negative 2, multiplied by 1 over negative 2, then plus the constant value c. So in this case, let's simplify again further. Okay, so we have 1 over y equated to x. So when we have x power negative 2 is the same as 1 over x squared, then multiplying this with 1 over negative 2 plus constant c. So I'm just simply simplifying this expression that we have. So let me just remove this part here. So in this case, we have 1 over y equal to, so we multiply x with whatever we have in the brackets. We are going to have x. We are going to have x or rather we can simply even write it just outside here. So we have x, then here we have 1 over negative 2x, then squared here plus the constant value c. So this is the answer, unless you want to simplify further. Otherwise, this is the general equation. Thanks once again, guys, for staying this far. Please like, subscribe, share, and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.